Hello my fellow developers and welcome to the second part of DateObject methods. Last time we covered get methods. Today we will be talking about set methods. Exciting, right? I will explain 7 pairs of set methods, where the first of the pair is non-UTC or local time zone method if you will, and the other one is UTC method. The remaining method will be toSetTime, which does not differentiate between time zones. Let's get right into it. First pair of set methods is setFullYear and setUTCFullYear, which allow us to set the year fraction of the date according to local time in the first case and according to UTC time in the second case. The return value is a new timestamp. Let's see it in action. First we actually output our variable new year to see the value of the date object in it. It is the same date and time as in the previous video, just a few minutes after midnight. I show both date value in string format and number of milliseconds, so we can better see what is happening when we change some fraction of the date later. Currently, my year's fraction of the date is equal to the local time value of 2022. However, when I use the setFullYear method, I will change it to 2021, just like the output suggests. Pay attention to the milliseconds timestamp that has changed in comparison to the original value. It is equal to 365 days less, or in layman's terms, 1 year less. So far, this is quite logical and easy to understand. However, in the case of setUTCFullYear, you might start shaking your head and think something is wrong. But bear with me and you will see that even though the change is a bit counterintuitive, it is also correct. When we set the year to value 2021 using setUTCFullYear method, we get a date object that is 1 year in the future in comparison to using setFullYear method. Why is that? Reason is simple. By using the setUTCFullYear method, we tell JavaScript to first rewrite the date as if our local time zone was UTC. This means that we get 31st of December 2020 UTC. And only now we replace the old year value of 2020 with the new value of 2021. So we get the new date of 31st December 2021 UTC. But when the output of the new date occurs, our own local time zone is used and we end up with the date of 1st January 2022 CET. So as you see, it is a little complicated, but if you think about it, the method works exactly as it should. The other set methods are exactly the same, only they deal with the different fraction of the date, specifically with months, days and hours. Let's see them in action as well. Let's first output our good old variable new year. Its current value is 1st January 2022, a few minutes after midnight, CET time zone of course. We first set a new month value with method setMonth, providing value 1, which is the index value for month February. This method sets the month for a specified date according to local time. No surprise, the new date has a month of February instead of January within. So far, so good. Now we use the method setUTCMonth, which sets the month for a specified date according to universal time. So our current date of 1st February, a few minutes after midnight CET, is turned into 31st January, a few minutes before midnight UTC. Now the method replaces the value of the position of months with the value of 1, which is February. New UTC date is 31st February 2022. But wait, there is no 31st February. Actually, there are only 28 days in February of 2022. But don't worry, because for the date object these numbers are just offsets. JavaScript simply counts non-existing 3 extra days as days within the next valid month, which is March. So what we end up with is the date of 3rd of March 2022 UTC, few minutes before midnight. Now we just need to transform it into CET so we can compare it with the actual result we get. So we shift it 1 hour forward and we get 4th of March 2022, a few minutes after midnight CET. And as you can see in the output, it matches. We can do the same exact date magic with the dates and hours, but I think at this point you understand the process. So if you want, you can stop this video now and try to apply the same logic to the examples for the set date and set hours. I will wait. Just for the sake of consistency, I will provide the definitions for these two pairs of methods, even though I am sure that at this point you know pretty well what they do. Pair of setDate and setUTCDate methods change the day of the month of a given date instance based on local time in the first case and UTC time in the second case. They both return a number of milliseconds representing the new changed date object. Methods setHours and setUTCHours sets the hour for a specified date according to local time in the non-UTC version of method and according to universal time in the UTC version of method. Again, both methods return a number of milliseconds representing the new changed date object value. We then have another 3 pairs of UTC/non-UTC methods that handle setting minutes, seconds and milliseconds respectively. Since time zones are shifted by whole hours, both versions of methods do exactly the same thing. They set their respective fraction of a date to a new value. Here are few boring examples to look at if you want. Just like the previous methods, the result of these methods is a number of milliseconds since the Unix epoch, or a new timestamp if you want to call it that. Just like with the get methods, you can set only specific values from a given interval to a specific date fraction. It's no-brainer really. For the minutes and seconds, there is a range from 0 to 59. For the milliseconds, it is a bit more, from 0 to 999. The last method I want to show you is a method setTime, which accepts a number of milliseconds as an input parameter, and based on that value, it sets the date object to the time represented by a number of milliseconds since January 1st, 1970, midnight UTC. I created a new date object variable called moment. I output its value into the console so we can see what date it represents. Then I assign the variable a new, different value. It is a number of milliseconds, of course, but slightly smaller one. When I output the new value, again, you can see I changed the date so it goes a bit into the past. And that's it. There's not much more to it. You can set whatever date you wish without the hassle of keeping track of time zones and whatnot. As long as you know the number of milliseconds since Unix epoch, or you have a Unix timestamp which you then need to multiply by 1000 to get the milliseconds out of seconds. And you are all set. Alright, those were set methods of date object, and this is the end of part 2 of the Date JavaScript Basics series. I know it was a lot, but you can admit it. It was interesting and you finally understand the date magic of JavaScript, don't you? That's what I thought. As always, thank you for your attention. I will be back soon with the third part of the date object series.